Welcome, everybody. So today we are going to be talking about ray optics, which is built on the fundamental assumption that light travels in straight lines. And we'll see later in the course that there are other different assumptions you can make about light that are also true that will give different behavior. But right now we're going to talk about what happens if you assume that light travels in straight lines. We are going to go ahead and represent light using rays, which are those straight lines. And so this kind of model for light is often called ray optics. Here is an example of a light ray. It is a straight line with an arrow on it that represents the direction that the light is traveling. And you can actually treat any source of light as a collection of a whole bunch of little point sources of light that are emitted in all directions. You can think of a point source as something like a light bulb or the flame on a candle, something that's relatively small that, again, is emitting light in all directions. You can think of, for example, the end of my pen or something like that as emitting light in all directions. And then if you wanted to talk about the whole pen as a light emitting object, you need to treat it as a whole bunch of little points along the side. So that is the basics of the model. Here, excuse me, is a diagram, a ray diagram for a single point source of light. Again, you can think of that orange dot in the middle as a really tiny light bulb, and then all of the rays are coming off of it in all directions. Obviously, I'm only going to draw a finite number of rays, but you really can't think of them as kind of being in all directions. I've got a little activity for you to think about here, which is putting a light bulb over on the left, putting a screen with a gap in it. You can see that in the middle. And then there are a whole bunch of dots on the right-hand side. And I want you to imagine putting your eye at each of those dots and looking at the light bulb to see whether or not you can see it. So I'm just going to stop here. I ask you to pause the video, take a moment or two, and see if you can answer these questions. All right, I'm going to go ahead and share my answers with you. I'll choose orange since my light bulb is orange. And the way that I'm going to do it is I'm going to draw some rays. I'm going to make a ray diagram here. And I know that light travels in straight lines, so I'm going to draw a straight line ray from from the bulb to each place where the eye is. And what you'll see is this one is in trouble, right? The light travels in straight lines, but there is a wall in the way. And so that light ray only makes it to the wall where it's going to get absorbed and is not going to make it to the eye. And it looks like the same thing is true down here. So there would be an example of a ray diagram, and I would be able to see this light bulb if I put my eye at any of those middle three locations, but I wouldn't be able to see the ray from the other two. If you want to collect all of this, you really only have to draw the edge rays. These ones kind of tell you whether or not any points inside of this range will be visible, or if the light won't make it to the points outside. So that's a good shortcut when you're doing radar. All right. So there's a few different important ideas here. One is if you want to see something, light from that thing has to reach your eye. And of course, you need to be looking at it. I can't see something behind me if the light doesn't make it from the thing to me. When rays of light hit most objects, they get absorbed. They don't continue through the object. And you can actually see an object from some places and not others if some of the light is blocked.